Hello, my name is Rhiannon. My PhD is biorefining of steel manufacturing co-production gases, and that means I take waste greenhouse gases from steel manufacture and I turn them into what's known as ethanoic acid. So it's a useful building block chemical for bioplastics, polymers, coatings and paints. It's really useful in industry, and we can use naturally occurring bacteria found in sewage sludge to form ethanoic acid. Now, the bottleneck of the process is actually the extraction of that acid once it's been formed, and that's something that I want to sort of demonstrate today and explain how we actually intend to go about. So I have a conical flask of just plain water. You're probably wondering why I'm wearing my waterproof coat inside, and it's to demonstrate something to you. So if I pour my water onto my coat, it runs straight off. So it has a hydrophobic property, and this property is really useful. So the material that my coat is made out of is PTFE, and this material actually has little gaps inside the coat. So it has a hydrophobic side, and then there's really small gaps so air can actually get through the coat. And this material we can actually use to extract our ethanoic acid at the end of our process. So ethanoic acid is also known as acetic acid, which is more commonly referred to as vinegar. So you all know what vinegar smells like. So I have a small vial of vinegar here. It smells good, makes me want chips. So it's volatile at room temperature, and that's another property that we can actually use to extract the acetic acid from our reactor broth at the end. So I have an empty conical flask, and I'm going to add a small amount of water to that flask. And I'm going to add my acetic acid to that water. So this is what we would get out of our reactor broth at the end. It would be a really diluted acetic acid solution. And you obviously can't, other than the smell, you can't tell that that's got acetic acid in it just by looking at it. From our reactor, it would also have things like nutrients to keep the bacteria alive. It would also have the bacteria. So what we have to do with this reaction broth first is filter it through a 0.1 micron filter, and that takes out the bacteria. We then wash the filter and put the filter bacteria back into the reactor so they continue producing our ethanoic acid. Once it's been filtered, we'll then put it through what we call a stack. So we take our membrane, same material as our waterproof coat, so it's robust, it's cheap, it's available, it's accessible. We put that into a stack. So we line them up, and we keep the hydrophobic side on the side that we're pumping in our reactor contents. So we gently heat up the reactor the effluent from the reactor, and this then puts the acetic acid, the vinegar, into its volatile stage. So it's a vapor, and the little air holes inside the PTFE membrane, these vapors can actually cross. And because it's got a hydrophobic side on one side, none of the water can cross. So we have our reactor effluent, our waterproof PTFE membrane in the middle, and we get our pure acetic acid out the other side.